Welcome to my channel Simple Concepts by DJ. Today we are going to study about this circuit analysis. So this is the circuit that has been given. So they are asking what is the voltage of point A with respect to point B. So we have the point A here and we have the point B here. So they are asking the value of the voltage at point A. What will be the voltage at point A? That is with respect to point B. Okay, so this is the question. What is the voltage of point A with respect to point B? And they have given this circuit diagram. This circuit diagram consists of two loops, loop 1 and this one is loop 2. Let us assume that this is loop number 1 and this is loop number 2. Loop 2. Okay, so first thing is that we need to analyze this loop 1. Loop is nothing but it is a closed path. Closed path is called as loop. So here this is a closed path. Similarly, this is a closed path. Since both are closed path, I am taking both the closed path as 1 and 2. So they are loop 1 and loop 2. So first thing is that I am considering this loop 1. I am considering the loop 1 and I am going to calculate the current, the value of the current that is flowing, the magnitude of the current that is flowing in loop 1, and I am going to get the value. Again, now I'm going to consider the value of the current that is flowing in this loop 2. But here an ammeter is there. An ammeter has been connected in this circuit and the meter reads as 5 ampere. So no need to calculate the current because the current which is flowing in this loop is being calculated by this ammeter. So ammeter shows 5 ampere deflection. So no need to calculate the value of the current in loop 2. It is enough that we calculate the value of the current that is flowing in loop 1. So let's get started. For calculating the value of current in loop 1, we need to use the voltage law by Kirchhoff. Okay, so I'm using the value of the voltage law. I'm using voltage law in order to calculate the magnitude of the current that is flowing in loop number 1. So let's get started. So this is the question, that is what is the value of the voltage of point A with respect to point B. So now I am considering loop 1. Loop 1. So this is loop number 1. So my direction of travel will be in the clockwise direction. So when I travel in the clockwise direction, first I need to assign the value of current here. Let us assume that I1 is the current. I1 be the current that is flowing in loop 1. Okay, so I1 will go here. Again, I1 will come and pass through 3 ohm resistor. Then I1 will go here. Then it will get into the negative terminal of the battery. It will reach the negative. It starts from the positive terminal of the 10-volt battery. It travels through the entire loop and finally it enters into the negative terminal of the battery source, of the voltage source of the 10-volt battery. It will get into the negative terminal of the battery. So now I am considering loop 1 using the voltage law. So here I1 is flowing through the 5 ohm resistor. So it will be minus I1 into 5, again minus I1 into 3, minus I1 into 3, again minus I1 into 5, minus I1 into 3, and it will be plus 10 equal to 0. So now minus 5I1 minus 3I1 equal to minus 10. So 5, 6, 7, 8, which will be minus 8I1 equal to minus 10. So I1 will be 10 divided by 8. So 2 4s are 8, 2 5s are 10, which is equal to 5 divided by 4. When I divide 5 by 4, 5 divided by 4, which is nothing but 1.25, which is 1.25 ampere. 1.25 ampere. So the value of I1 which is flowing in loop number 1 is 1.25 ampere. So I am writing here as I1 equal to 1.25 amps. I1 is 1.25 amps. Now no need to calculate the current that is flowing in loop 2 because Loop 2 has a ammeter which shows the deflection of 5 ampere. It shows a 5 ampere deflection over here. So 5 ampere current flows through this circuit. Now they are asking in the question, what is the voltage of point A with respect to point B? Therefore, voltage at point A with respect to point B, with respect to point B. So this is the parameter that we need to find. Voltage at point A with respect to point B. So this is the least possible pathway that I can reach from A to B, that is AC, CD, DB. So they are asking A with respect to B. So this is the pathway, but while calculating, I will travel in the reverse direction. That is from B to D, D to C, and from C to A. From B, I'll take this path in order to reach A. So for that, here the current that is flowing here will be 5 ampere. Okay, this is the 5 ampere current. Since this direction of the arrow is in this direction, the current will flow in clockwise direction. It flows in the clockwise direction. So I am taking this direction as the direction of current in loop 2, that is 5 ampere. 5 ampere current flows in the clockwise direction in loop 2. So I am going to calculate from B to A through BD, DC and CA. So now using the voltage law, so here when I travel from B to D, it will be from B to A, it will be minus 5 into 3. Minus 5 into 3. Again here, when I travel from D to C, it will be plus 8. When I travel from here, I encounter a current that is coming in the opposite direction of the direction of my travel. So what I do is I add plus sign and put I1 into 3. I1 into 3. Okay, which is nothing but voltage at point A with respect to point B, which is called as VAB. Which is VAB. So I know the value of current I1. So it will be minus 5 3s are 15. Minus 15 plus 8 plus I1 is 1.25. 1.25 into 3, which is nothing but VAB. That is voltage at point A with respect to B. So it will be minus 15 plus 8 plus what is 1.25 into 3? 1.25 into 3, which is 3.75, which will be 3.75 equal to VAB. Therefore, 3.75 plus 8 minus 15 equal to minus 3.25. So the value will be VAB is equal to minus 3.25 volts. So the answer is VAB, that is the voltage at point A, with respect to point B, that is VAB, is equal to minus 3.25. This is the voltage that we need to calculate. Okay, we got this value VAB equal to minus 3.25 volts. Okay, thanks for watching this video and please do subscribe.